JavaScript info/coordinates https://javascript.info/coordinates. 13th of June 2020. Coordinates. To move elements around, we should be familiar with the coordinates. Most JavaScript methods deal with one or two coordinate systems. Relative to the window, similar to position fixed, calculated from the window's top left edge. We denote these coordinates as client X, client Y. The reasoning for such name will become clear later when we study event properties. Relative to the document. Similar to position absolute in the document root, calculated from the document top left edge. We denote them page X, page Y. When the page is scrolled to the very beginning, so that the top left corner of the window is exactly the document top left corner, these coordinates equal each other. But after the document shifts, window relative coordinates of elements change, as elements move across the window while document relative coordinates remain the same. On this picture, we take a point in the document and demonstrate its coordinates before the scroll left and after it right. So here's the diagram. Left diagram, we have page Y, page X, client X. And they are both the same, it appears. And then on the right, it seems that as you scroll, page X and client X are the same, but since you have vertically scrolled, page Y becomes much larger than client Y. So let's that kind of makes sense because you have this scrolling content and a lot of its overflow is being hidden, and you're still, that page Y is still a coordinate that is local to that scrolling content. Let's scroll down. When the document scrolled, let's go here. When the document scrolled, page Y document relative coordinate stayed the same. It's counted from the document top, now scrolled out. Client Y window relative coordinates did change. The arrow became shorter as the same point became closer to the window top. Element coordinates, get bounding client rec. The method lm.getBoundingClientRect returns window coordinates for a minimal rectangle that encloses lm as an object of built-in DOM-Rect class. Main DOM-Rect properties: x/y. x/y coordinates of the rectangle origin relative to the window. Width/height. Width/height of the rectangle can be negative. Additionally, there are derived properties: top/bottom, y-coordinate of the top-bottom rectangle edge, left/right, x-coordinate of the left/right rectangle edge. For instance, click this button to see its window coordinates. Get coordinates using button.getBoundingClientRect for this button. I guess we could click it. Alright, little pop-up, and I can see, can I scroll through this? No, it's an alert. So it says javascript.info says x is 10, y is 63.125, width 410, height 22, top 63.125, bottom 85.125, left 10, and right 420. If you scroll the page and repeat, you'll notice that as the window relative button position changes, its window coordinate y/top/bottom, if you scroll vertically, changes as well. Here's the picture of lm.getBoundingClientRect output. So we have another diagram here. We have an x and a y coordinate of the left and the top, and bottom there's a dashed line. Not sure what that denotes. I think it's just a guideline. We have height and width of this element, and we have right and bottom. And so it looks like right and bottom appear to be global coordinates relative to the screen, so they're client coordinates, I believe. And the width and height are the width and height of the object you're querying. X and Y are also client coordinates. So this is very much in global coordinate space. As you can see, x/y and width/height fully describe the rectangle. Derived properties can be easily calculated from them. Left equals x, top equals y, right equals x plus width, bottom equals y plus height. Please note, coordinates may be decimal fractions such as 10.5. That's normal. Internally, browsers use fractions in calculations. We don't have to round them when setting to style.left/top. Coordinates may be negative, for instance, if the page is scrolled so that elem is now above the window, then elem.getBoundingClientRect.top is negative. Okay, we have a little information box. Why derived properties are needed? Why does top/left exist if there's x/y? Mathematically, a rectangle is uniquely defined with its starting point, xy, and the direction vector, width, height. So the additional derived properties are for convenience. Technically, it's possible for width/height to be negative. That allows for directed rectangle, e.g. to represent mouse selection with properly marked start and end. Negative width/height values means that the rectangle starts at its bottom right corner and then grows left upwards. Here's a rectangle with a negative width and height, e.g. width equals negative 200 and height equals negative 100. So here's the diagram. So we see the top left still in the same position and the bottom right still in the same position. And we notice that the direction vector for the width and the height is going up towards the top left of the screen, originating from the bottom right of the screen. That's a little bit odd, but I've never used something like that before. But I'm not gonna be surprised if there's an actual use for it, especially because, well, they're showing it right now, right? As you can see, left/top do not equal x/y in such case. In practice, though, elem.getBoundingClientRect always returns positive width/height. Here we mention negative width/height only for you to understand why these seemingly duplicate properties are not actually duplicates. Okay, that makes sense, yeah. They're not actually duplicates because you're going to lose the direction vector information. If you just keep track of these static points, you're not going to have that direction vector. Like, there'll be no such thing. So I kind of get why width and height are not exactly the same thing as these static points, because these static points do not convey direction. Internet Explorer and Edge. Don't use Internet Explorer and Edge. I know they keep on trying to force this browser on people. I cannot uninstall it because of a recent update. The browser wars are real, but do not use Internet Explorer and Edge. Public service announcement. Anyways, Internet Explorer and Edge. No support for x/y. Internet Explorer and Edge don't support x/y properties for historical reasons. So we can either make a polyfill, add getters in domrect.prototype, or just use top/left, as they are always the same as x/y for positive, width/height. In particular, in the result of elem.getBoundingClientRect. Let's keep going. Coordinates right/bottom are different from CSS position properties. Yes, I believe that's because I was doing some jQuery, and when you try to get coordinates, there'll be computed values versus the actual CSS values you set. And you may, depending on what you're doing, you may want one or the other. In the particular scroll bar thing I'm working on, I actually want the actual CSS properties and not the computed values. So let's read this again. Coordinates right/bottom are different from CSS position properties. There are obvious similarities between window relative coordinates and CSS position fixed. But in CSS positioning, right property means the distance from the right edge, and bottom property means the distance from the bottom edge. If we just look at the picture above, we can see that in JavaScript it is not so. All window coordinates are counted from the top left corner, including these ones. Element from point xy. The call to document.elementFromPointXY returns the most nested element at window coordinates x, y. So when we say most nested, we also can think of most nested as the topmost element. Because when you nest something, if you have a div and you put another div inside of it, so you take div A and you put div B inside of it. Div B is the most nested, but it is also conceptually on the top of div A. So I find most nested to be kind of confusing, or at least in this case, because element from point, we're kind of should be imagining like a ray coming from the user's screen and drilling through the z-axis of the layout and stopping when it hits an element. And thinking of it as layering makes a lot more sense in this case than thinking of it as what is more or less nested. I mean, they are both technically correct ways to think of it, but I think this is the improper mental model for understanding this function. So element from point xy. The call to document.elementFromPointXY returns the most nested element at window coordinates xy. So I'm going to reread that in a way that makes more sense. The call to document.elementFromPointXY returns the topmost element at window coordinates xy. The syntax is let elem equal document.elementFromPointXY. For instance, the code below highlights the outputs. Sorry, let me read that again. For instance, the code below highlights and outputs the tag of the element that is now the middle of the window. Let center x equal document.documentElement.clientWidth divided by 2. Let center y equal document.documentElement.centerHeight divided by 2. Let lm equal document.elementFromPoint with center x and center y as parameters. lm.style.background equals red, alert lm.tagname. And it looks like there's an ability to demo this if you want to go to their site, which is https://javascript.info/coordinates. As it uses window coordinates, the element may be different depending on the current scroll position. For out-of-window coordinates, the element from point returns null. The method document.elementFromPointXY only works if xy are inside the visible area. If any of the coordinates is negative or exceeds the window width/height, then it returns null. Here's a typical error that may occur if we don't check it. Let lm equal document.elementFromPoint with parameters x and y. Comment. If the coordinate happens to be out of the window, then lm equals null. lm.style.background equals empty string, colon, and then there's a / error and an exclamation mark. And that's because, trying to access a property on something null gives you a null pointer dereference error, but they don't really have a concept of pointers in JavaScript, but that's what's really happening. I forgot the exact error in JavaScript, like attempt to access property on undefined, or undefined does not have this property, something like that. Using for fixed positioning. Using for fixed, in quotes, positioning. Most of the time, we need coordinates in order to position something. To show something near an element, we can use getBoundingClientRect to get its coordinate, and then CSS position together with left top or right bottom. For instance, the function createMessageUnder and then lm.html as parameters below shows the message under lm. Let's scroll down and try to see the entire snippet if we can. This snippet is 24 lines. I don't think it's going to fully fit on my screen here. So let's just start at the beginning. I want enough to where we can pause and not have the regions of the screen be obscured by the YouTube controls. Line 1, let lm equal document.getElementById with parameter string chords dash show dash mark. And then we end the statement. Line 2 is blank. Line 3, function createMessageUnder, taking parameters lm and html, opening the function body. Line 4, comment createMessageElement. Line 5, let message equal document.createElement with parameter string div lowercase. Line 6, comment, better to use a CSS class for this style here. Line 7, message.style.css text equals, and here's a string. Opening the string, we have position, fixed, semicolon, space, color, space, red, and then closing the string and closing the statement. Line 8 is blank. I'm going to scroll down a little bit more. Lines 9 through 13 have been highlighted a tannish color. Line 9, comment, assign coordinates, don't forget px. Line 10, let chords equal lm.getBoundingClientRect, invoked, and then the statement is ended. Line 11, empty. Line 12, message.style.left equals chords.left plus string px, and closing the statement with a semicolon. Line 13, message.style.top equals chords.bottom plus the string px, and closing the statement with a semicolon. Line 14, blank. 15, message.innerHTML equals HTML. 16 is blank. 17, return message. 18 is a closing curly brace, which ends the function. And let's just review what that function name was. The function was createMessageUnder, taking parameters lm and HTML. So scrolling down to the usage on line 20, that's just a comment. And then line 21 is an explanation of the usage. Adds it for 5 seconds in the document. Line 22, let message equal createMessageUnder, taking parameters lm and the string hello world, hello, comma, space, world, with an exclamation mark. And that's the end of the statement. Line 23, document.body.append, message as a parameter. Line 24, set timeout, and set timeout function is taking an inlined anonymous function or a function expression. It's also written in a lambda style, so the function starts by just opening and closing some parentheses, equal sign with a greater than operator to create like an arrow, because it's an arrow function, and then message.remove, and invoking remove without any arguments, a comma, and then 5,000 milliseconds, and then close paren to close off the set timeout function, and then a semicolon. And so I'm just going to say what that literally is, because I think that's going to be hard to visualize if you're just listening. So on line 24, set timeout, open paren, close paren, space equals greater than space message dot remove, open paren, close paren, comma, space 5000, close paren, semicolon. And that reads as set timeout, message dot remove, 5,000 milliseconds. click the button to run it. So we have a little button for running the snippet, so let's just click that, see what happens. Hello world, and it's happening right underneath the button. That's pretty cool. I definitely could have a use for something like that that demonstrates some things I need to know. And the button is labeled button with ID equal within quotations chords dash show dash mark, comma, the message will appear under it. Continuing with the text, the code can be modified to show the message at the left, right, below, apply CSS animations to fade it in, and so on. That's easy as we have all the coordinates and sizes of the element. But note the important detail. When the page is scrolled, the message flows away from the button. The reason is obvious. The message element relies on position fixed, so it remains at the same place of the window while the page scrolls away. To change that, we need to use document-based coordinates and position absolute. So I'm going to click this button again and see if it pops up somewhere else. It popped up underneath the button last time. I'm still in the same basic position. If we scroll here, oh, okay, I see what's going on. Okay, so it popped up in the same place, but then when you scroll, it's like, whoop. Okay, got it. So to change that, we need to use document-based coordinates and position absolute. So document coordinates. Document relative coordinates start from the upper left corner of the document, not the window. So of the document, not the window. So I believe they're talking about the client area. When they say that upper left corner of the document, I believe they're saying the client area. I could be wrong here. In CSS, window coordinates correspond to position fixed, while document coordinates are similar to position absolute on top. Yeah, I might be wrong here. We can use position absolute and top/left to put something at a certain place in the document so that it remains there during a page scroll, but we need the top coordinates first. There's no standard method to get the document coordinates of an element, but it's easy to write. The two coordinate systems are connected by the formula page y equals client y plus height of the scrolled out vertical part of the document. Page x equals client x plus width of the scrolled out horizontal part of the document. Okay, so client is not going to be affected by scroll, but page y and page x are. So that is something important to note. I'll probably need to make a note of that really quick, but I won't because I gotta keep on reading this. I don't want to slow this down here for anyone. But just remember, client X is not affected by the scroll, where page X is. Same thing with the y-axis. The function getCoords lm will take window coordinates from lm.getBoundingRect and add the current scroll to them. Get document coordinates of the element. So this is a snippet here, and that was line 1, and it's a comment. Get document coordinates of the element. Line 2, function getCoords with parameter element, or lm, sorry, and opening the function. Line 3, let box equal lm.getBoundingClientRect, invoked without any arguments, semicolon. Line 4 blank. Line 5, return, and opening up some curly braces. We're creating an object literal here. Line 6, we have a key of top with the value box.top plus window.page y offset. Line 7, we have a key of right with the value box.right plus window.page x offset. Line 8, we have a key of bottom with the value of box.bottom plus window.page y offset. Line 9, we have a key of left with the value of box.left plus window.page x offset. Line 10, we have a closing curly brace, closing the object literal, and a semicolon to end the statement. Line 11, we're closing off the function with a closing curly brace. In the example above, we used it with position absolute, then the message would stay near the element on scroll. Let's say that again because I think I butchered the English there. In the example above, we used it with position absolute, then the message would stay near the element on scroll. So I think the English might just be weird, or I'm not interpreting that correctly. The modify create message under function. So we have a modified function. Line 1, function create message under, taking parameters lm and html. Opening the curly brace. Line 2, let message equal document.createElement with a string of div, all lowercase. Closing the function call and ending the statement. Line 3, message.style.css text equals, and then a big string with position, :absolute, semicolon, space, color, space, red, and closing off the string and closing the statement. Line 4 is blank. Line 5, let chords equal get chords invoked with lm. Line 7, message.style.left equals chords.left plus the string px, semicolon. Line 8, message.style.top equals chords.bottom plus px within a string and then a semicolon. Line 9 is blank. Line 10, message.inner HTML equals HTML. Line 11 is blank. 12, return message, and 13 closes off the function with a closing curly brace. Then we have a summary. Summary. Any point on the page has coordinates. 1, relative to the window, lm.getBoundingClientRect. Relative to the document, lm.getBoundingClientRect plus the current page scroll. Window coordinates are great to use with position fixed, and document coordinates do well with position absolute. Both coordinate systems have their pros and cons. There are times when we need one or the other one, just like CSS position, absolute, and fixed. Tasks. Scroll down. Tasks. Find window coordinates of the field. Importance 5. In the frame below, you can see a document in the green field. Use JavaScript to find window coordinates of corners pointed by with arrows. There's a small feature implemented in the document for convenience. A click at any place shows coordinates there. Alright. So we have a little application here. Click anywhere to get window coordinates. That's for testing to check the results you get by JavaScript. Click coordinates show up here. So let's give that a shot and see kind of like what we're going to see here. I'm kind of afraid this is going to open up a new window. Nope. Okay. So it looks like these are the window coordinates. Guys, so it wants me to get the local coordinates, I'm assuming here, of this thing right here, of this green block. So let me scroll this a bit and change where it's positioned really quick, and I want to see if that is drastically going to change what right here says. So if I click that now, we get 16, 15, and if I move it up, do you still get somewhere around the same thing? 19, 15, yeah. So this region seems to be our little applications. Our application's global coordinate space looks like it's defined by here. I don't really have much time to mess around with that. We're just going to continue reading, but that's pretty cool. Your code should use DOM to get window coordinates of 1, upper left outer corner, that's simple. 2, bottom right outer corner, simple too. 3, upper left inner corner, a bit harder. Bottom right inner corner, there are several ways, choose one. The coordinates you calculate should be the same as those returned by the mouse click. P.S. The code should also work if the element has another size or border not bounded to any fixed values. And then we have open sandbox for task. Show a note near the element. Importance 5. Create a function, position at anchor, position element that positions elem depending on position near anchor element. The position must be a string with any of 3 values. Top, position elem right above anchor. Right, position elem immediately at the right of anchor. Bottom, position elem right below anchor. If used inside function show note anchor position HTML provided in the task source code and creates a note element with given HTML and shows it in the given position near the anchor. Here's the demo of notes. So some lorem ipsum text, note above, note below, note at the right. And we have another sandbox, open sandbox for the task, and this is at https://javascript.info/coordinates for this page. Most of this just looks like it is it's exercises now, so it's not really more information to read. But I'm just gonna, for completeness, since we're almost near the bottom, I'm just gonna continue reading. But this would be a valid place to skip out right now. Show a note near the element absolute. Modify the solution in the previous task so that the note uses position absolute instead of position fixed. This will prevent its runaway from the element when the page scrolls. Take the solution of that task at a starting point to test the scroll. Add the style, body style height, 2000 pixels. Another task, position the note inside absolute. Extend the previous task, show a note near the bottom, show a note near the element absolute. Teach the function position at anchor, position elem, to insert elem inside the anchor. New values for position, top out, right out, bottom out. Work the same as before. They insert the elem over /right /under anchor. Top dash in, right dash in, bottom dash in, insert elem inside the anchor, stick it to the upper /right /bottom edge. For instance, and we have a code snippet. Line 1, comment, show the note above back quote. Line 2, position at, open, paren, block quote, comma, top out, comma, note. 3 is blank. Line 4 is a comment, show the note inside block quote at top. Line 5 is position at, open paren, block quote, comma, top in, comma, note, and close paren, semicolon. Then we have the result. We have some lorem ipsum text, and we have little messages. Note top out, note top in, note bottom in, note right out. And I can definitely see how that would be useful for some tooltip kind of text. As the source code, take the solution of the task, show a note near the element absolute, and then we have a solution button. And then previous lesson, next lesson. Comments. If you have suggestions what to improve, please submit a GitHub issue or pull a request instead of commenting. If you can't understand something in the article, please elaborate. To insert few words of code, use the code tag or several lines, wrap them in pre-tag for more than 10 lines. Use a sandbox. So I don't know what this sandbox is, but JSBin and CodePen. Is that PLNKR, I guess? Like Plunker, I guess, maybe? Is how you're supposed to pronounce it? I don't know. And then there's some comments. Tutorial. And nothing that I'm going to read. I'm just going to scroll over the comments for kind of the consistency. And we're done reading this article. And that was https://javascript.info/coordinates.